Okay, so there's one thing I want to do before I start the electronics shielding portion. So the electronic shielding will be a continuation from last session, which was on Tuesday. But I want to show a video and sort of talk over it of a machine I did a long time ago for a school in Georgia. I think you guys will get a lot out of it because I haven't uploaded it on YouTube, but it was on Vimeo for a long time. What I'm doing is not me, it's actually one of my employees is filling up the water in the water reservoirs, but it takes a little bit of finesse to do that with a laser, because we're doing two water systems, one for the laser and then one for the spindle. And the way he does it, I mean, he's been doing filling up water with these low power pumps. You have to sort of do it in a certain way. But if you're wondering about the hurricane, it was hitting the house pretty hard yesterday. The wind got pretty high. I'm gonna take a look at the shingles. I hear that some of the neighbors have some shingle issues. So I'm gonna take a drone and fly it over the house and inspect the roof. So kind of excited about that. All right, so I'm gonna go ahead and start the video. I don't wanna waste anybody's time or wait for anybody else to come in. So here we go. All right, so this is Juan, one of my ex-employees. Well, he's an employee that I had in Texas, and when I moved away from Texas, unfortunately, I had to move the business as well. So this is him. So this right here, I don't think you can. Yeah, you can see my cursor. This portion right here, this is the heat exchanger. It's got two fans and a radiator, and this is the reservoir. And this one is for a 40-watt laser. It's oriented vertically on the Z-axis. We did this for a lot of the Fabricator Pros. This is the machine you're looking at here is the Fabricator Pro. I can't remember what these two, I'm pretty sure these two power supplies are for the X-axis and the Y-axis. Well, the X-axis has one, and the other one probably serves as the Y-axis and the Z. And I call the one that goes along the gantry the Y-axis, and the one that goes up and down the Z-axis, obviously. But the one that goes along the entire table, I call the X-axis. A lot of people call that the Y-axis. And I do that because it's safer for me as an operator for a CNC machine, because the way I look at it when I'm looking at my cam drawing, I look at the X-axis on the bottom going left and right, and the Y-axis going up and down. And when I look at the machine, I look at it in the same way. So for me, it makes more sense. I don't look at one end of the machine. I look at this. I stand at the side of the machine. So the X-axis is to my left and right, just like it is on the screen of the cam. I generally tell customers to think in that way to orient their machine, or assign their X and Y in a way that it makes it safer for them. And don't go with some standard that is on the internet, because a lot of people get kind of triggered on whether it should be the X or the Y or whatever. But in this case, I just like to do the X on the gantry. All right, so let's take a look at what he does on this one. So I believe right now he's evacuating the water for the laser water reservoir. And how's the sound? Is that okay? I believe he's turning on the compressor so we can probably get a lot of the water out, or yeah, he's getting the rest of the water out of the system with the compressor. And the other guy that's in the video is his name is Clayton. He used to work for me as well. We were like a big happy family. And this is my garage in another house. The entire house was devoted for BuildYourCNC at the time. All right, let me see if I can get the audio here. Not really sure how to do that, but let me see if I can do that real quick. No, I don't have a way to do that, unfortunately. That I can see, at least. Oh wait, audio output capture. Let's try that. Okay, no, yeah, we can try that. Let's see if this works. All right, let's see if you can hear this. Can you hear it? How is it now? Okay, great. I'm going to rewind it just a little bit. Okay, he's going to start speaking in a moment. Hopefully it's going to be loud enough. Also, I believe we're doing this to instruct the end user for the machine on how to fill up the water in the water reservoir and also fill up the CO2 laser. Is my voice still echoing? It could be because the output is also taking into consideration. Wait, hold on a second. Testing. How's that? Is that better? Okay. I'm going to increase his voice. Let's try that and see what happens. Distilled water, probably with a little bit of antifreeze potentially to get rid of any microbes that would be.
You're going to have to put it back once you get this.
Yeah, this is the high tension return line for the laser. And that's the laser power supply that's mounted on the top of the Z-axis. So you can see the way I mounted the laser. Let's see if I can get a better shot. So I mounted it vertically. There's a spindle that goes right here. Actually, you can see the spindle right here. This water reservoir here and the heat exchanger is for the Z-axis spindle. It's for the spindle. And then the one on the back is for the laser. The tubes for the water reservoir and the water circulation goes through the what do you call it? The cable chain or the cable carrier. Just for the we couldn't put all of the water stuff on the Z-axis. Obviously, there's not much room. But I like to put on all of my machines. I like to put the water reservoir and the heat exchanger and the pump right next to the spindle. I do that with all of my machines, and I have my machine. My personal machine is like that, and it makes it. For me, I think it's better for water circulation. It's a very small closed loop rather than having these tubes going all over the place through the cable carriers and then down into a lot of people just put it into a bucket. And that's how a lot of Chinese spindles are sold nowadays, is they just have a pump that is submersible and it goes right into a bucket and you just pump it that way. You can get a better view of the laser here. This is a 40 watt laser. And you can see the inlet and outlet of the water. I can't remember which one is the inlet and outlet, but I'm guessing that the one on the top is the inlet, the one on the bottom is the outlet. And getting water in here is challenging because you want to get all of the air out of the system, and that's difficult in a system like this. That's the high tension line.
So you got your other terminal back here, and it's a brass fitting.
And we use because there's vibration obviously with the spindle. If you're using the spindle and the laser is not being used at the time, we use a silicone collar, I guess you'd call it, sleeve or something like that, and that reduces the vibration. The customer has been using the machine for quite a while, and there has been no damage to the CO2 laser, so this is a pretty good solution for that. And that too, it keeps it from it keeps it in place.
Here.
These mounts here are HDPE, so they're a little bit slippery, and you don't want to tighten them too tight or it's going to put too much pressure on the glass.
Careful, you already.
So Bleach, you say you usually blow on one end of the water hose so it's completely empty. Yeah, that's what he did with the other one. He may do that to this one as well. I haven't watched the entire video. And we also do that with the compressor so we can clear out the line as well, just in case there's some kind of buildup. Yeah, that's the air line that
From the air pump up here.
it's connected to a compressor, so it blows out the.
So
I don't think I'm gonna. I mean, I still sell the machine, the Fabricator Pro, but
you can actually remote.
I don't know if I'd recommend doing the laser in this way anymore. I would probably recommend putting one of the smaller diode lasers on there instead. If you need the power and you need to cut
That's it.
other materials that the CO2 laser could do, that's one solution. So you can see the HDPE mounts, you have that sort of zigzag in there. That's just for not applying as much pressure. So now he's emptying the spindle water. Let's see if he does a compressor. He might do it. Yeah. So he's blowing it while it's attached to the spindle. So he's doing exactly what you were saying. By the way, I got a parallel PCI CAD and breakout board, and it solved my problem with Red Board. Okay, good. If you have a Red Board on hand, I can tell you the exact problem with it. I think it's a driver related problem. Let's go ahead and do that when we do the when we start doing the tests for the shielding. I can plug it in and you can tell me how to do that. I think we're taking the water out for transportation, actually, to transport this machine. So
I'm thinking how.
yeah, this is getting ready to freight the machine. I think now I'm taking the chains off. What I think I'm doing here is we may be disassembling the entire gantry so it's more easily transportable. So you can see how I have the chain. By the way, this machine uses chain drive on both X and Y axes. So it uses two idler sprockets on each side and then a drive sprocket next to the motor. Each side has its own motor, but there's still, actually no, this one has a single motor and has a pillow block at the end, where that pillow block is it's a shaft connected to the motor. The motor is coupled with the shaft, a longer shaft that goes all the way to the end. And what that does is it removes any racking from the machine. I like roller chain for CNC routers because it allows the chain to be tensioned and you're eliminating a lot of the backlash by doing that. And this is me trying to roll up the chain so it's easy for the customer to get back out and install. This gantry is really heavy. We also transported an 8-foot gantry. This is a 4-foot, well, for 4-foot travel. We've also, it turns out to be around maybe 5 feet wide or a little bit more. No, it's probably about 5 feet wide. The other machine that I did was 8 feet by 17 feet, and the gantry itself was about 9 feet wide, or 9 feet long, I guess. So yeah, we're disassembling this entire machine for transport. So I don't think we need to really watch that, unless you want to. I'm kind of curious if we have the footage of us taking the gantry off. All of these parts, these brackets here, they're all routed by the wooden machine that I have, the Greenville. So all of these are sort of machined or milled from a wooden CNC machine. And to keep these frames sturdy, we just use these sort of wooden panels to keep this from racking. And it works really well. I don't actually sell the assembled machines anymore because it's just too hard on my back and all the heavy lifting I have to do. So I stopped doing that a while ago, actually. So we're just talking. All right, so this looks like it's about the end. Oh yeah, look at that. Hold on. Let's go back. So we do take it to the end here, and we are about to take it off. This is a scary thing, actually. You can see the amount of space we have in the garage is not very much. Okay, so this is interesting. The linear rails I have there's probably one long linear rail here, and then I have a shorter piece here that is abutted to that longer piece. So that smaller rail can keep the rail bearing block can stay on a rail because it's safer to keep it on the rail, obviously, because the ball bearings will escape if you don't. We could have taken it off the back and then put a little plastic protector in there, but this way is a lot easier. So you can see that we didn't have to slide it off the end. We can just take that small portion and just lift it up. Okay, so that's it. Alright, so thank you for watching that, and I'll probably be making that into its own video so I can upload it on YouTube. So let's take a look at the Red Board. So you're saying that there's potentially a driver issue with that? And what is Drupal? Is that related to this issue? So it looks like Drupal is a CNC controller. All right, let's see here. Yeah, I'm looking at Drupal. It's a CNC controller. I didn't make one for this. All right, so yeah, it's like Mach3, but it's plug and play with the Red. Oh, interesting. So the Red Board is compatible with this Drupal CNC control software? Oh, that's really interesting. So Mach3 doesn't have a driver that allows the Red Board to be used in a reliable way, but Drupal has developed a driver for the Red Board. Is that what you're saying? How much is the Drupal CNC? Let me see if I can get this video capture here. Yeah, 5,000 lines is actually quite a bit. I think Mach3, the license allows you unlimited, but if you don't get the license, I think it's 500. So you had projects that had a lot more than 5,000. I can tell just by looking at. Let me see if I can duplicate. Okay. All right. You can still hear me, right? All right. I'm going to make a little bit of a modification here. I'm setting up scenes in OBS, so I can just click on buttons and the scene will appear. So in these live streams, I'm still getting used to live streaming. Setting up scenes during the live stream, unfortunately, is the way to do it, because this is the way as from a reaction from chat, I can understand what kind of scenes I need to make. So I'm going to add a display capture. Here we go. So this is the program you're talking about, Drupal CNC. Is that correct? Hey CNC, how's it going? In the beginning of this video, I showed a video of the Fabricator Pro and us sort of packing it up for a customer. This was a video I showed I had a long time ago, and I wanted to sort of explain what was going on a little bit with the process of what was going on in the video, so I can upload that to YouTube. And it showed a lot of really interesting things with the water reservoirs and getting the water out. It didn't show putting water in. I was hoping it would actually do that, but this is the one of my aluminum machines. It's a Fabricator Pro, and it's an 4x8 machine, and we were sort of packing it up or getting it ready to be shipped through freight. Okay, so Bleach had a discovery with the red card, the one that we're using for the shielding tests, and he found out that the R&R motion, which is the driver for that card, is buggy, and he uses or Drupal made a better driver for that card. So I'm really interested in that, and I want to see what the pricing is and stuff, and I wouldn't mind putting this on my website and just offering it for sale. Just not offering it for sale, but providing a link for it. Especially if it's a one-time, if it's not a subscription type of program, because I don't like those. It looks like a nice interface. I'm trying to look for a price. Do you know what the price is, Bleach? I'm also going to be putting a lot more controllers on my website. I don't know if I'll have these, but definitely have like the smooth stepper on there, and many more coming up. And actually CNC time-lapse is helping me with all of that. Connection diagrams. Okay, here it is. The full license is only $198. That's cheap. For CNC software, it's really good. So, and it's good that you can try it for 5,000 lines. That's a lot of lines of G code. So that'll give you a really good idea or understanding of if it's good for you, if it's good to use. So maybe I'll do a test of this today, Tuesday, maybe, who knows, we'll see. But I'd like to test this out and install it for the first time, see if I can figure it out. That might be a good way to show installation from me doing it the first time, and the pitfalls of me doing it for the first time. It's Russian, be careful. Interesting. A venture capital firm that sort of works with the CIA. I found out that from Joe Scott, I think that's the video, the YouTuber. All right. So yeah, I'll do that next time. All right. So let's, I guess we can start looking at the main topic of today. Today's experiment, the CNC electronics shielding, session number 2. Okay, I'll use a let's see what driver. I'll use this motor here. It's a 425 ounce inch, NEMA 24, and a 542 driver. I need to get my phone set up so I can see chat. All right. This is going to be a tiny little bit of a tutorial on how to connect a motor with a driver and then driver with a controller. Oh, it gets echoey because I'm near the other mic. Yeah, that makes sense. All right, let's see. Which wire goes where? Red, blue, I think goes A+. Red, blue is the red. And again, use wire ferrules. Okay, I just muted my other microphone, so it should be good now. There we go. I'm going to leave this shield floating for now. Well, we can use that shield. We can use this setup for doing the experiments for shielding. The wire gauges are... What are these wire gauges? I think these are 18. 18, yep. All right, let me get a power supply. I'm going to take, let's see. I already had these available. That's nice. Of course, I can't find my screwdriver. I might have to go with something else. Plus, red, V minus, black, 48 volts. And let's get some power. Ground, neutral, and live. We'll start with ground. I really want to find out where my screwdriver is. 1 millimeter squared. Yeah, you want to try to... Bigger gauge obviously is better. I think 18 for these motors are fine. These are drawing 3 amps. And it also depends on how long the wires are going to be, the cable. So the longer the cable, increase the gauge. There's a lot of tables out there on what gauge you should be using for what amps. And when you have multiple phases, the voltage is not split between phases. You're still having constant, or not voltage, but current. The current is still the same on all of the wires because it's like a sine wave. They increase up to that current on each wire. There are 2 wires per coil, so this is actually a little bit better. But it goes to a single wire here, so it's good to use a larger gauge if you can. I'm not going to plug this in yet. In some portion of the live stream. Okay, where was I? I'm right here. All right, so I'm going to add the ground and V plus to the driver. See if I can get my head out of the way. Also, a question that I get a lot is, where do I put this shield? And that's a really good question. I've done some research on shielding, where to put the shield. It's obviously ideal to put it on ground or the body of the cabinet or something like that. You can essentially just screw it right down to the cabinet, the plate of the cabinet right here. And you have a good connection to ground as long as you connect the main ground to the cabinet, which is normally done. So that's what I would suggest. You can put it on DC or DC ground here, but this would be a last resort. And this is something that I've researched, and it's still acceptable, but it's not ideal. All right, now I'm going to take the driver. I'm going to go ahead and remove these wires for now. So a single axis is good, right? You don't want more than 1 motor on there for this experiment. I'm not going to be connecting the smaller power supply. All right, so I'm going to use the x-axis if that's what you want me to do. Let me see if I can get some shorter wires. I've got these that already have the wire ferrules on there, but only on one side. Any axis is okay. X or Y are easier as jog button is ready. Yep, I agree. So one of the comments that I got, actually it was a reaction video, he was saying never loop a wire from one terminal to the other, but I don't see any reason why you shouldn't do it. If you guys know any reason why I shouldn't, let me know. Otherwise, it's really the shortest path to ground, to that specific signal. If I was doing ground, then it would be the shortest path path to ground, which I will be doing because that's the way I generally hook these up. I'm going to turn on the light. It feels like it's getting darker in here. Now it's too bright. Let me tone down the ISO. Yeah, that's what I hear. So I'm going to do it anyway. I don't care. All right, I'm going to use this side. So I'll use red for the step. No, yeah. And I'll use black for the ground and white for the direction. I usually do it, I think I do it the other way around. I use red for the, I'm going to use white for step. Let me confuse everybody and just completely go off. All right, so XP is the pulse. This is ground. And XD is the direction. Pulse is the same as step. Tug on it, very tight. I don't know, I think it causes too much glare, don't you think? Let's see if I can change the angle. Maybe that's better. But now it blocks the light. Oh, I can't win. Still might be better to see. Yeah, that's fine. Okay, and now the black to ground. And they have 2 ground terminals on this board, and that's very convenient. That kind of shows you that they expect you to connect these for positive, the signals, and then the ground is negative, and not using the 5 volt because the 5 volt only has 1 terminal, and it makes more sense to use multiple, because when you have 4 axes here, you're gonna run out of space. So putting 2 wires in 1 terminal is fine, but putting 4 wires in a terminal. All right, so we have the signals plugged in. We need to put them to the driver. So let me get a tiny one, a tiny little wire, and that will be the little loop. I should have gotten a black wire. So make sure you use a black wire and not a red wire like I'm using. See, this would be an ideal thing, an ideal place to put a wire ferrule. And this will go to pull minus and direction minus. Okay, so I've got that looped. So it's going to go in here and then loop here. And there's no like ground loops going on here. So you know, there might be a little bit of a ground loop here because they may be already connected, but I don't think they are. If they're connected in the back, then there would be a ground loop, but they're not. So this would not cause a ground loop. It's just going straight to this this terminal and the signal. And if there is a problem with that, explain it to me, because I haven't had a problem with that before. I use 5 volts as you stated, I believe, but it shouldn't matter here. No, it won't matter. The signals are a signal, you know, it's just either active low or active high. All right. Okay, so the controller is connected to the power supply. I mean the driver. The driver is connected to the power supply. The power supply is connected to power. The motor, so the driver is connected to the power supply. The driver is connected to the power. The driver is connected to the controller. The driver is also connected to the power supply, and the driver is connected to the motor. Now we need to get the power supply connected to the computer and start the software. I'm going to turn off that black box. All right, it found or it's telling me that the Poki's device is unavailable. I'm not going to be using that anyway. So I'm going to go to config. Yeah, this is bad. Let me turn down the ISO. So I need to go back to config plugins, and I'm going to disable the Poki's and then enable the R&R mode. It would be nice to know, hey Bob, how's it going? It would be nice to know if there's somebody that has a better driver. All right, so let's go here, R&R motion, that looks good. Reset, let me plug in the, actually I want to test something. You should see the red LED on the red board. Okay, so I know it's communicating by pressing the left and right buttons, so that's good. You can see the DRO is changing. All right, so let's plug in the power supply and see if this thing spins. Of course, now it's too dark and it does not spin. So I probably wired this incorrectly. Wait, white was step, not direction. That's why. I wired this incorrectly. You can see the white wire in the direction. So the white wire I had as step. So I I confused myself because I was unsure which one I was going to do. So step is definitely white. So let me unplug everything. Okay. It's not perfect, but it's good enough. All right. This is for testing purposes. All right, let me plug it in. That's the router. Oh, notice the router has only 2 prongs, neutral and live. Doesn't have the third. And look at the housing. It's metal. I was holding on to that thing. I wonder if that's normal. I don't know. That's kind of odd to me that exists like that. Usually when you have a metal housing, you have a ground. All right, so let's go ahead and see this spin. I think I need to slow it down. Yes, I weathered the storm. Thank you, Bob. Yeah, it was scary. I've been through lots of hurricanes, but I was just like in my garage and not very calm. All right, so the x-axis I'm showing, I know the ISO is going to kill me again. Well, I'm going to have to describe it to you. The velocity is 100, which is slow, and the acceleration is 20, but the steps per is probably way off. So I probably need to bring that down quite a bit. So I'll make that 500 just to have some kind of number in there. I think I must have it on like full step or half step. Okay. All right, so it's spinning. Let me blinky blink. Yes, you can bring the motor near to the computer so we can see both. Yeah, I'll do that. Bob says the housing goes to neutral. Okay, yeah, we talked about that. So I'm guessing they're already assuming that your house shares the neutral with ground. Okay, so bleach. Cool. Okay, let's replicate the problem. Lower your Excel to the lowest it can get. Okay. Let's do it. Let me move the motor to the computer. See if I can get a wider shot. I'm not sure if that's going to give you guys any better information. That's my jib you just heard. My jib meaning camera jib. Okay, how's that? What should be in focus? The motor? All right, so let's take the acceleration, go way down. So I'll go to 1. Save axis settings, press OK. Okay, all right, so what's next? Now jog to full speed and remove your finger. It should work fine. Right, it decelerates as expected. Excelling and decelling, it should be fine. But if you stop jogging mid-excel, it jerks. Okay, let's see. I have a feeling that it may show that jerkiness in higher current situations. I know what you're talking about, by the way. I had that scenario when I was using a NEMA 42 motor, and it did do a big jerk. Oh, okay, let's go higher speed. Config. But I have experienced that. Let's go to 1,000. Well, let's go to 2,000 because 500 is a very low steps per. And I didn't look at the setting. I'm going to increase the microstepping, so we'll see if we can replicate the problem that way too. That's a stall. Yeah, that's a stall. So that speed is too high for this. Mine completely lost about 30 degrees. Buzzes like crazy, but parallel port is fine. Oh yeah, that stall. Yeah, the stall didn't happen with the parallel port? Okay, that's interesting. Yeah, that's an interesting fact that it didn't happen on the... I should try this with the Pokies board to see if that same thing happens. All right, let's take a look at the jog speed. All right, so the jog speed is going to be right here. I know it's going to be very difficult for you to see. And what we can do is we can look at the position of this, and then we can do a stall. Obviously, it's going to cause a problem because when the motor stalls, it stalls and it doesn't know what the computer is telling it essentially. So on my machine, I have closed loop steppers, so that wouldn't happen because the driver and the motor are working together to make sure that that doesn't happen. I've checked the position each time my mill moved about 0.1 millimeters. After 10 things, it was 0.13 millimeters. Okay. Yeah, so that's interesting. I should try the, if you're saying this stall like this right here, if you're saying that doesn't happen in a parallel port situation, then I should start, excuse me, I got a frog in my throat, in my lungs. I should try the other control program, the CNC control program. Would that happen in the other control program? Yeah, let me do that. It will. I think it will stall because the velocity is way too high. Yeah, let me lower the velocity. I'll lower it to 2,000 or 1,000. Interesting. Okay, yeah, that's good. Good to know. Okay, I see the problem. Yeah. Okay, so let's install Drupal and see what happens. Is everybody game on that? Or do we want to go to shielding and then I can do Drupal later? It happens in programs too before installing. I don't understand. Check jog speed real time in monitor. You mean the feed rate, right? Are we talking about Drupal or are we talking about Mach3 at this point? Right, yeah, it still says it's moving because the motor is stalling, but the computer doesn't understand that the motor is stalling. It doesn't know that. It doesn't have any feedback. Okay, good. So Mach 3 only. So it does happen with feed rates too. Interesting. Let me try a G code real quick. I'm going to go to the MDI. I'll do a rapid G0 X0. Well, I want to get to X0 or get to some number. Let's see, G0 X10. I'll probably want to put this in a file actually, because right when I press enter, it's going to try. Okay, that worked. And then G0 X0. So that didn't happen there. Yes, if it was a servo motor has encoders, so it definitely would give you feedback. But there are also closed loop stepper motors that I have on my machine. I can show that to you. Actually, let me show that to you real quick. Since you're asking the question, it doesn't connect to the controller, but it does it between the driver and the motor. I'm learning. So this right here is where it connects to the driver. This is the encoder here. There are 6 wires dedicated just to the encoder of the motor. So the driver knows what part of the rotation that the motor is at the time, and this is the wires going to the coil of the motor. So these are stepper drivers and they're stepper motors. And with the stepper motors and drivers being closed loop, I think you have the best of both worlds, because the servo will, because of the PID control, you have a transient response. It has to come back to 0, or keep trying to get to the position that it needs to be in. And it keeps trying over time, and it gets closer and closer, but doesn't actually get there. The stepper motor has exact positioning, and it doesn't have to worry about that. All right, let me lower my. Yeah, well, yeah, I agree with you with the driver. I don't think it's the Red Board, like you said. It's probably the driver of the Red Board. I don't have Discord set up right now. Let's do that in the next session if we can on Tuesday, so I can set that up, or I can attempt to set it up now. Yeah, I think it's better to do it next session, and this, it's okay that we're doing all this too, because this also will help in the shielding tests as well. So I'm going to. What monitor are you talking about? If there is a problem using the R&R Motion DLL and I can't find a suitable replacement, I'm just not going to recommend the Red Board anymore. Or I will recommend the Red Board, but only using it with Drupal. The jog speed jumps up when you when you're stopping the jog. All right, let's look at that. You can hear the motor. I'm going to make it so you can see the screen, but you'll be able to hear the motor when it stops. And I'm going to see if I can give you a really good close-up view of the jogging. So the feed rate is over here. And you can also see the DRO at the same time. So I'm going to go ahead and run it and get my mouse away from the motor because I know it's going to jump. Okay, that was one test. I'm going to go the other direction. Looking at the feed rate. So do you see it jump? Okay, yeah. So if you see this, and if this doesn't happen on the Drupal, I want to test that and see it. And if that is true, I am for sure not going to be recommending the R&R motion anymore. Yeah. Let me lower the. Well, no. I'm going to increase the microsteps and see if it still happens with even smoother motion. So give me the story. Why do you hate Drupal, the software? All right. So I'm going to make sure let me see if I can get this. I'm looking at the table on the top so I can see the settings where they are currently. So it looks like 1, 2 is on and 3 is off. Yeah, that's 2.84 amps. That's correct for this motor. And let me look at the microstepping here. So 4 is on. That means it's full current. That's why it was kind of hot. 5 is off. 6, 7, 8 is on. Okay, that's 400 steps. Yeah, that's half step. That's going to be rough. So let me bring it to 1600. Off, off, on. Okay, so that's changed. I'm going to unplug this and plug it back in because I don't like having power, any kind of power on this while I'm doing that. So the Drupal UI is bad. I use dark screen and custom macros and stuff on Mach3, and there's no way to change the screen setup on Mach3. I mean on Drupal. Okay, so that's unplugged long enough. I'm plugging it back in, taking all the metal away from the area. See if I can get everything in the shot. Probably want to lower the ISO just a little bit, or yeah, maybe that. Let's plug it in. It's going to go really slow because of the change in the microstepping. All right, let's see if it happens when I'm going as I'm accelerating. I did hear it. I'm going to put my mic next to it, and it's the same bump that you were talking about. Not there. I think I got to the highest. Yeah, you hear that? Let's do another test where I hear a slight little bump. It's interesting it doesn't stall, but it's because of the microstepping. So let's do an experiment. Let's set 0 at a specific angle, and let's keep doing that same thing over and over again and see if we when we go back to 0, it's at that same angle. Let's go back just a tiny bit. So that's, I would say, let's say that's 0 degrees. So let's go ahead and 0 this out, and I'm going to do this over and over again, and then we'll go back to 0 and see if it maintains its position. This would probably be the better test of all of this. I'm going to see if I can get a little closer to the motor at least. So you should be able to see everything now. Well, at least the motor. So I'm going to do it now. Okay, I heard the little pop. Yep. Five, 6, 7, 8, 9, 10, 11. So let's go back to 0 and see where it lands. Let's go to the MDI and just do a G0, X0. I could have just pressed go to 0. But it landed exactly where it should have landed. Maybe I should do this at a higher. Should I do it more times, or should I maybe change the microstepping lower and see if I can replicate the problem? I'm going to do that. There's a little bit of lag on video, so I don't want to waste any of your time, so I'm going to go ahead and do that, assuming that you think that would be a good idea. All right, so I think I'm going to go to 800, which is between 400, which I had it, and 1600. So let's do that. So 800 is on, off, on, on. So I need to bring number 5 down. So on, 5 is on, 6 is off, 7 is on, 8 is on. All right, let's try this again. So 400 was definitely giving me some major stalls, but 1600 wasn't giving me a stall at all, but I could hear that little bump. Replicating problems is not the easiest thing to do, but I want to give this the best chance possible, because I can't recommend anything that doesn't work to a customer. All right, but at this point it's like 0.01 degrees each time. Yeah, so I mean 800 may amplify this, so let's see. And if it doesn't, I'll just do it more times. Especially with microstepping. Microstepping, you know, each step is extremely small, so if it's losing steps, you know, you're getting really, really small degrees for sure. All right, so this is vertical. Maybe it isn't. Maybe it's off vertical. Let's make this 0 though, anyway. Okay, let's make that 0. So 0.042 was it. Now let's go to 0. So that probably does look a little bit more. Let me put this wire in the back so it doesn't keep falling. And it's nice that it's on this table, because the table kind of amplifies the sound. All right, so it's at 0. I hear the little bump. I'm going to put the microphone a little closer so you can hear it. It seems to be louder at higher speeds. And yours is at 6,400 steps per revolution. Wow, that's interesting. So you shouldn't have heard anything at all. That's really fine. How many times do you think I should do this before we stop the test and go back to 0? Oh, right, you stalled it. Interesting. All right, let me stop there, and let's go back to 0. And if it lands at 0, then I'll just keep doing it. Huh, I went far. That's perfectly vertical. I can keep doing it. Maybe it's my, you know what, I should send you my plugin and see if it still happens. I'm tentatively going to be informing customers, any new customers at least. Let me try a few more times while I watch the chat. Well, the 400, it's stalled. I wouldn't say that that's a bump. I would say that's a stall. I never recommend setting drivers at half or full. It's always a quarter or an eighth or a 16th. And 400 is a half. And that's going to always run really rough. By the way, I did not 0 it, so just so you know that's important to mention. So this should add to the error. You can even see the motor move when it does that bump. I don't like the bump anyway. I think I probably wouldn't want to recommend this. The combination of the Red Board and Mach3, just because of that bump. If it goes away with parallel port and Drupal. I should look also for another software, CNC software, that works with this Red Board. Oh, I know, I love Linux CNC. That's what I used in the beginning, and I didn't want to go to Mach 3 because I felt that Mach 3 was too complicated. Linux CNC is so easy. In fact, I programmed my entire pick and place machine through Linux CNC. I'm wondering if the issue would be more pronounced if the motor was mounted because of inertia. Okay, let's try that. Let's go back to 0. It's going to travel quite a ways. Yes, Back to the Future. You know, it's probably good that I'm not doing it in both directions. I'm only doing it in one direction, so the error should multiply. If I did it in both directions, then I would be canceling that out probably. Okay, it is perfectly vertical. I cannot replicate this problem. But I did learn something. Don't set your driver at 400, like if I'm talking to a customer. If they do that, then I'm going to tell them not to. Which I always do anyway, but if I can't figure out the problem and I ask that question, maybe that's their problem. You will clip the video and see the degree. Okay, yeah. Well, I mean, the motor has moved, so, but that's pretty much dead on. I wonder if the 6400 steps per revolution would have caused the problem, because it loses torque at higher microsteps. And the other thing that I noted is that this isn't mounted. So, okay. So what do we want to do going forward? What I'm thinking is going to Drupal, installing Drupal, and I can do that in the next on Tuesday. I can install Drupal on camera. So I'm installing it for the first time, and I'm looking at the process of installation and everything, and that would help everybody else out too. I don't really want to stop selling this Red Board. I mean, I don't really make any money from it. I think I make maybe $10 per sale, and I get one sale every 2 weeks or something like that. So it's not like it's not going to break the bank if I took it off my website. But if there's an alternative, this is a very inexpensive board, and it solves problems for a lot of people. With at least their financial reasons, because a lot of people just can't afford to get the other controllers like the Poke's 57 CNC and others like this Smooth Stepper and stuff. Those are a lot more expensive, and the Red Board is like, you know, you can get it on Amazon for $25. You can get it on AliExpress for about $10, maybe less. And on my site, I offer the Amazon link, but I also sell it for $35. So, you know, it's an inexpensive board. So it would be nice to find a solution, but if there isn't, yeah, I won't be recommending the board at all. So if the Drupal works, I'll be making sure that I mention that in the web page. All right, so it is 4 o'clock, but I want to make one announcement regarding the times I'm going to be starting. I want to start at 1 o'clock rather than 2 o'clock every day. From 1 o'clock to 2 o'clock, well, actually from like 11 o'clock to 2 o'clock, I'm pretty much twiddling my thumbs waiting to do a live stream. But I don't want to do it too early, because that takes a lot of other folks around the world out of being able to watch the live stream. So I think 1 o'clock would be a good time. So from now on, tomorrow's stream, which is going to be the STM32, I'll be starting at 1 o'clock, and every day after that. So I'm going to sign off. Thank you for watching. Next Tuesday I'll be continuing this little saga of missteps, and I should probably get sort of a consensus before I start videos, so I can change the text on the screen. It is a bit to the right? Okay. All right, cool. All right, so it's probably like maybe 2 or 3 steps off, potentially. Thank you, Bob. Thank you, CNC. Thank you, Bleach. All of you that were participating in the chat, I really appreciate it. the more chat participation I get is, it makes me feel like I'm actually helping somebody. So thank you for that. And I will see everyone on Friday or Monday or Tuesday.